Well, hello people, how are you? Good to see you again. I got another demonstration for you. I want to get right into it. This one is called the circles of life. Okay, I'm gonna like this one. Okay, so let me get this going here right now. Okay, so first of all, as you know, I'm Tom, and this is the Infj experience, and this is going to be called the circles of life. I'm getting right into it. Okay, now first of all, people, everything has to start. The first fundamental circle of life is going to have to be starting as the molecule, the atom, basically. Okay, that's the first component of your circle of life. Let me demonstrate what's going on. I'm going to give you an example, okay? Now, basically, an atom is the center. That is the nucleus of a molecule, all right? And around this, we got orbitals. We got spinners around there. We have photons, protons, neutrons, electrons. A lot of trons going around that orbital, okay? So a lot of things spin around there, and they're going pretty fast. So they're all spinning, and that makes up a molecule. Now understand too, people, that depending on what it is, what material it is, whether it's a living thing, whether it's an inanimate thing, a rock versus let's say a leaf in a tree, there are different elements, different particles that are spinning around there. There might be more photons and protons or neutrons depending on what it is, okay? So that's what makes up all the different matter, things like that. All right, but anyway, so I'm going to get into this diagram in just a minute as well, all right? So basically what we got going on here is the fact that I'm going to just give you an example as to what's happening exactly in the spinning of this atom, all right? Now, I want to just imagine you are a NASCAR driver. Let's just say you are a NASCAR driver, and you were on that track, and there's 40 other years. There's 40 more, and let's imagine this is the molecule, and you're driving around that track. Okay, you're spinning, and you got an oval track. You're spinning. Now let's just say hypothetically, you could spin this. You could drive this car almost to the point of the speed of light. Okay. Now, the speed of light is 186,000 miles per second. That is your speed of light. Now, let's just say you were driving your car that fast. Okay, that'd be pretty fast. I don't know if it can go that quick, but let's just say. But anyway, let's just slow it down. So you're just shy of the speed of light. Now, you're driving around that track. Okay, let's say this is your track and you're driving around there. There's your car. And basically what's going to be happening is you're going to be tailgating your own bumper. Let's just say you got to the point you were just shy of the speed of light, and all of a sudden you tailgated your own bumper because you went that fast. All of a sudden, basically you're going to be looking at yourself in the past in front of you. Yeah, think about it. And now you're going to look in the rearview mirror of the guy in front of you looking at your future. Kind of a paradox there, but that's what would be happening, okay, hypothetically. Now let's just say all of a sudden you rev your car up just enough to go the speed of light, all right, and you said, I'm gonna, instead of crashing into your tailgate, you merge with your car. You just become one with the car in front of you, basically merging with yourself. Okay, now that example is, okay, now there's 40 old NASCARs doing that. Let's just say 40 other cars doing that, and they're all doing the same thing. They're merging. That is basically what your particles are doing in this molecule. They are all going the speed of light and merging with themselves, creating matter, creating just mass in its sense, okay? All right, now this is getting deep, people. Now let me also elaborate on this fact that not only have they merged with themselves. Okay, let's go back to the NASCAR. Now, they've merged with themselves. I already explained that. They take that one little NASCAR here. Okay, there he is. He's got his wheels and his tires. Okay, oh, that's a little car. That's awful. All right, let's just say a NASCAR. What's the weight of it? You know, the engine, the body, the chassis, everything about it. 2,000 pounds? Let's say 2,000 pounds. All right? Now, this thing is driving around the track. Now, what's happening is the fact that you have attained the speed of light, okay? You have driven around this NASCAR so fast at the speed of light that you have taken that 2,000 pound car and you have intensified the weight of your car because you occupy every single part of that track. You are everywhere in that track. And now you have multiplied the weight of your car because you are everywhere. You occupy that. You become like a loop. You've actually changed into like a loop of yourself as you looped around at the speed of light. Now, because that's a 2,000 pound car, you've added how many thousands of pounds to your car because you've actually added mass. You've added weight to yourself. Now that's what these particles are doing. That's exactly what all these particles are doing on there. Okay? And that is how mass is, that is how it's attained, because of the fact that you're intensifying the weight of it with the speed of light squared, I guess. Okay, I don't know if Einstein ever came out. I think Einstein had some of this part there. Okay, now let's look at this. Now what is this diagram? Okay, that's basically, you must have seen the old atomic, whenever you see like atomic fusion and things like that, they give you the diagram of the atom. It's never like that. That's one dimension. That's flat. That's two dimensions. It's actually three-dimensional, because these particular particles aren't always necessarily rotating in a flat plane. They're revolving in a spiral. They are having ellipticals. They are having eccentric orbits. They are weaving, and they have more of that dimension. So they're not just doing this, they're doing this, okay? And also, so we already understand that. Now, here's another thing. Now, not only have they intensified the weight, they become mass, as I've described, they're also doing this here. There might be another atom over here. Let's say there's a whole other atom system. And this guy's spinning right over here, okay? He decides to jump ship, and now he jumps over, he joins that one. Okay, he might have just jumped out of there. He spun it around 3 million times. He said, that's enough. I'm starting to join on that track over here. All right, same thing down here. Let's make that guy an atom. Now this guy over here, he's spinning. He decides to jump, and he says, okay, I'm going to start going around that atom. Okay, and same thing over here. It could be an atom. This guy decides to go over here. But my point is, same thing here. Okay, this guy's jumping around. He decides to go over here. Yeah, and then maybe there's an atom up here. After this, there's another one. He goes up there. My point is that you are now, this molecule is now weaving. These particles are jumping at some point and fusing and merging with other molecules, giving this entire molecule a woven dimension. That's why we're all together. That's why we're kind of held together. And that's why everything is held together, because of that. Because these atoms are doing this, and they're doing this rapidly. This is all in the time that they're in. All right? That's how deep it gets, but they're in circles. That's what I mean. People, this is the basis of the circle of life. This is where it all starts from, exactly where that comes from. All right? Now, I'm going to go on to the next phase here. Okay, next phase, all right? Now, I want to talk to you about these shells of the particles that are rotating. Now this is still the molecule. This is still your atom, and these are your particles. That's protons, neutrons, whatever it might be. Okay, we're going to just call it anything. But now certain ones have a shell. In other words, they have orbitals that go around the particle itself, giving this thing more dimension. So this could be a proton. And yeah, it's got these orbitals that rotate around it. It might have several. It might have, it might have 2 or 3, depending on what it is. These orbitals have shells as well. So not only are they rotating around this atom and making it the molecule, adding weight, adding dimension, adding the mass as I've described, but these shells are doing it as well. They're in the speed of light as well. So all of that is adding dimension, adding up complexity to this molecule even deeper than it is with these shells. All right, it's quite an elaborate and deep system you got there. Okay, so anyway, that's part of the shells, and that's also what the dimension of that molecule is. Very complex. Next phase. Okay, next phase here, people. All right, now we're going to span out a little bit. You've learned about the molecules and the complexity of that system, okay? Now that's a microcosm of this right here, the solar system. I know you're thinking to yourself, yeah, wait a minute, it looks a lot like a molecule. It's basically, okay, well, basically people, it does, and it reacts very similar. Again, it's all in circles. Everything's in circles, circle of lives. And they actually are similar in a lot of ways. This is a macrocosm of a molecule, all right? And the molecule is a microcosm of a solar system, okay? But trust me, people, they have almost the similar characteristics. So if I was to describe to you what a solar system was doing, you can almost say, all right, well, wait a minute. Whatever I just told you about a molecule, it's similar. The only thing is, we're not going the speed of light. We're seeing it as our Earth year is 365, and 1/4 day is our Earth year. Now, let's just look at this. Here we have the sun, okay, which is basically like the atom, almost relatively like the atom. Okay, you have Mercury, you have Venus, you have Earth, and etc. Then you have Mars, and then you have an asteroid belt. I didn't draw the asteroid belt, by the way. And of course you have Jupiter. Now this is as far as I took it. I mean, I could have drew Neptune, Saturn, Uranus, Pluto. I could have done all those. I just didn't want to go that far. But we understand that there's 9 planets, eight or nine planets in the solar system. Now my point is that each one of these planets, of course, they rotate around the sun. Now again, the solar system is not a flat system. I know we see diagrams and it always looks like it's on one plane, like a record, but it's really not. I mean, Earth and some of them have their own, their own eccentric systems and their own revolutions around the sun, which gives it a dimension. So it's similar to the atomic symbol that I had earlier. But my point is that they're all very similar. They're all interconnected, and they're all in circles. Now, the shells that I told you that each one of the particles had, that they had their own orbitals. Now, you have moons. You have moons on each one of our planets, have their own orbitals, do they not? Almost like the orbitals in the particles of the molecule. It's deep. But trust me, people, it's almost the same thing in its own way. It's just a deeper understanding of that. Now, people, I'm going to tell you a theory. Yes, Tom has theories. My theory is this. I'm going to understand a lot from the molecule and how it reacts because I understand the solar system. And I'm going to tell you, my understanding of the solar system tells me this. Now, there are exact amount of days we revolve around the sun. It takes 24 hours for one day. All right, now it takes 365 1/4 days to rotate around the sun. You understand me, people, right? So in that time, it's always exact. It's always perfectly exact. The amount of revolutions and the distance that it takes to get around the sun that we know. And each and every one of these planets are the same way. And of course, we have our moon. There he is. There's the moon right there. There he is, right there. Now that moon has its own time, and it takes basically 12 revolutions around the Earth as it's going around the sun. All right. So we have basically 12 months. It's roughly 28, 30 days for it to circle around the Earth, etc. Okay. Now my theory is this: those particles that are in a molecule. I know we always they're going so fast, we can't slow them down enough to actually study them. But those particles spin like the days of a planet, and they are exact. If it takes 365 revolutions around our own days and nights, these particles have their own exact time that they are spinning around the atom. This is my theory, people. I've never heard it said before, but yes, this is my astrotheorist mind coming out. You heard it here first, people. That is my theory. I don't know if it means anything, or if it's not gonna win me any kind of Nobel prizes, people. I understand that. I'm just saying that's my theory, okay? The bottom line is circle of life. This is expanded out, all right? So, people, on to the next phase here. Okay, people. Back to my next phase here, okay? So we had the solar system. We told you about the solar system. Now we're going to the next circle of life, and that would be the galaxy. I know, please forgive me with my horrible artistry, people. I just kind of threw it together. I know, looks more like an octopus, doesn't it? Kind of looks like a hurricane, maybe, you know. It's got that spiral look to it, you know. Hey, all in circles, right? Hurricanes, they're in circles too. All right. But anyway, my point is this, people. Now, this is a macrocosm of a solar system. Now, you got to figure also, too, now, there are collections of stars and solar systems in these armbands. These are what they represent. Each one of these bands represents an arm of, and they are full of solar systems. And there could be billions of them and billions of them, as Carl Sagan used to say. Billions and billions of solar systems in these arms. All right, so I just drew this one random little one over here. That would be basically our sun. We're just randomly in the arm of the Milky Way galaxy. But bottom line is, it's in a spiral and it is in a circle. Now, it might take billions and billions of our Earth years in order for this thing to spiral, to spin. But it does. It spins. It rotates in the galaxy as well. In the universe, it does spin. But again, it takes billions of our Earth years for that to happen. So it's in a slower, much slower time continuum. All right? Again, somewhere, somebody might be seeing that in the speed of light. Maybe they just see that thing spinning. Yeah, somebody bigger and higher than us. Well, anyway, people, that's basically the point of that, is that it's basically a macrocosm. Now, here's something interesting to learn, is that everything is related. Everything kind of spirals out. And now, if you look at our own body, you look at the fact that we have cells, we have molecules, obviously, that make up our cells. And our body is composed of, body is composed of cells and many multitudes of cells and different types of cells. I mean, there's muscle cells, there's blood cells, there's brain cells, many different types of cells, but of course they're put together differently. They have their own unique pattern to them because of what they are, because of what part of the body they represent. Now, if you look at it, I mean, a cell, in a sense, is a collection of many multitudes of molecules that all have the similar characteristics building up that cell. Now, if you look at a spiral of a galaxy, in a sense, it represents it's similar to a cell in a living body, in a sense. Now, I don't write the rules, people. This is just how I interpret them. This is just how I see them. But again, all part of the circle of life and how they're all kind of interconnected and how they're all kind of similar in their own way. Now, it gets deep, people, because this is just how life is built. This is how the creation is. So, all right, people, on to the next phase here. All right, so people, you've seen basically my demonstration how circles work. I started from the smallest one and kind of branched it off to like almost the biggest one that I could think of, and how they're kind of similar in their own way. Now, that's basically what the circle of life is. Now, people, if you can have thousands and thousands of examples on how life and how just the earth, nature works and is based on circles. You can even see weather patterns. You can see certain storms and tornadoes are always circular. You can see the way spirals and things like that are happening and just cause and effects of nature and things like that and physics. And they're always spirals, almost like gears that are working against each other, these causes and effects. And there are so many different examples of how circulatory systems work as well. I mean, take our body, for example. I mean, gosh, we breathe in oxygen. We exhale carbon dioxide. Our heart takes in the oxygen and it feeds it and enriches it through our blood cells, which goes through our body and it nourishes our body. It returns back. It takes the carbon dioxide out. It expels out and just to start over again. But in a sense, it's all in circles. It's a circulatory system. So it's all even called that. And you could say that there's a lot of things that are in common with just the way we're designed, the way we are built as human beings. And there's many examples of that. I could go on all night and how there are examples. Now also think of the examples that ingenuity, just what man has created. Okay, look at the engines. Look at the advancements in just science and technology, and how a lot of them are based upon just the circular mechanics of the world, of the circular mechanics of functionings. It's like circular. I mean, you look at the gears in a basic car engine. I mean, you look at it. I mean, it's a gas combustion engine. You look at the pistons; they go up and down. They just work a crankshaft, which in turn works the transmission, goes to the drive shaft, spins the tires, which are all circular. So anything that is in motion, that has to be created, that has to have some form of life, even in machinery, has to be circular. And you look at examples, and that's all what it is. So everything is in circles. But then you say, but Tom, we're INFJs. What does that have to do with being an INFJ? People, bottom line is, this is stuff that we think. Our mind goes like this. And somehow we have to make sure that it computes into things in our life. A lot of times we can. We can use these examples of these circular natures in order to understanding nature, seeing how physics, seeing how storms, and somehow understanding it. It comes to us in a lot of ways, that there's examples and there's lessons to be learned in just how things in physics operate in these circular motions. I mean, just the description that I'm giving you is it's a deep demonstration, I understand, but a lot of times our minds are thinking this way. But a lot of times these lessons come to us in slight subtle ways, and how we say, oh, that's why I should do it this way, because nature, because physics, because science does this. You see? And somehow I relate to this and how it helps me with my daily life in some ways. I don't have any examples, but people, you know what I'm talking about. I mean, that's basically what it is. And ultimately this, people, I'm going to conclude with this. Now, I tell you that I'm going with science and physics, but I also tell you that there's a spiritual element to me. I do believe in a higher creation. And I kept alluding to something being into like almost seeing this as a deeper way. I alluded to God. Okay? People, ultimately, understanding these things, God has given us the ability to have, that we reflect Him. We have the mind to reflect God. He made us in His image. And all these things about physics and science and understanding and how the universe works and seeing the circular way is His way of telling us, educating us, and giving us His mind, giving us His intellect in order to basically reflect back to Him who He is, that He is our Creator and He is our God. And that's how He created us, to reflect back. He made us in His image, ultimately. So I understand a lot of it is scientific, but also there's spirituality in there as well. So this is the conclusion, people. A lot of times just understanding these things is just merely a reflection, like a, hey, pat on the back. God, you did a good job. That's basically what it comes down to. Okay, people, I said a lot. Listen, people, thank you so much. If you've hung around to the end of this video, thank you very much for being here. And I want to thank you. And please, give me some thumbs up. Support my channel. Subscribe to the channel. And give me some comments if you like this content. And I'll continue to make more of this kind of content. So anyway, people, thank you very much again. And until the next time, have yourself a wonderful rest of your day.